So welcome students for the online class on municipal and industrial wastewater. So let me start with the topics which we have covered in the last online class. So we have discussed about the topics which I have posted as a notes in your WhatsApp group. So in the last class itself, we have discussed about the effect of effluent discharge on streams as well as methods of industrial wastewater treatment. That means what is the significance, why the industrial wastewater has to be treated, etc. we have discussed. Now, today we'll discuss about the two methods of industrial wastewater treatment. First among them is volume reduction and second one is strength reduction. Now in detail, we'll discuss about the methods of industrial wastewater treatment. So depending upon the quantum, concentration, toxicity and presence of non-biodegradable organics in an industrial wastewater, its treatment may consist of any one or more of the following processes. First among them is volume reduction, second one is strength reduction, third one is neutralization, fourth one is equalization and proportion, fifth one is removal of suspended solids, sixth one is removal of colloidal solids, seventh one is removal of inorganic dissolved solids, eighth one is removal of organic dissolved solids. As per your syllabus, we have to discuss in detail about all these methods of industrial wastewater treatment. As I told you, today we'll discuss about two methods, that is volume reduction and strength reduction. Come to the volume reduction. In general, the first step in minimizing the effects of industrial waste on receiving streams and treatment plants is to reduce the volume of such waste. This may be accomplished by first, classification of waste, second, conservation of wastewater, third one, changing production to decrease waste, fourth one, reusing both industrial and municipal effluents as raw water supplies, fifth one, elimination of batch or slug discharges of process wastes. Now we'll discuss in brief about all these methods. So come to first one, that is classification of waste. If wastes are classified so that the manufacturing process waters are separated from cooling waters, the volume of water required for intensive treatment may be reduced considerably. Sometimes it is possible to classify and separate the process waste themselves, so that only the most polluted ones are treated and the relatively uncontaminated are discharged without treatment. Next one is conservation of wastewater. Water conserved is waste saved. For example, a paper mill which recycles white water, that is, water passing through a wire screen upon which paper is formed, and thus reduces the volume of wash waters. Concentrated recycled wastewater are often treated at the end, since usually it is impractical and uneconomical to treat the wastewater as they complete each cycle. The savings are twofold. Both water costs and waste treatment costs are lower. Steel mills reuse cooling waters to quench ingots, and coal processors reuse water to remove dirt and other non-combustible materials from coal. Now, third method I can say is method to reduce the volume is changing production to decrease waste. Yes, Jai Shri Ramat.
Yes, sir.
Yeah, is it audible clearly?
Yes, sir.
Okay, then. Let me continue. Yeah. So we were discussing about the volume reduction by changing production to decrease waste. This is an effective method of controlling the volume of waste, but it is difficult to put into practice. It is hard to persuade production men to change their operations just to eliminate waste. Normally, the operational phase of engineering is planned by the chemical, mechanical, or industrial engineer, whose primary objective is cost savings. The sanitary engineer, on the other hand, has the protection of public health and the conservation of natural resources as his main consideration. Yet, there is no reason why both objectives cannot be achieved. Waste treatment at the source should be considered an integral part of production. Cost the company money to change its method of manufacture in order to reduce pollution at the source, the sanitary engineer can do more than simply enter a plea for the improvement of mankind's environment. The reduction in the amount of sodium sulfite used in dyeing or sodium cyanide used in plating and of other chemicals used directly in production has resulted in both reduction in quantity of wastewater and saving of money. The balancing the quantities of acids and alkalis used in plant often results in neutral waste with saving of chemicals, money and time spent in waste treatment. Fourth method of reducing the volume is reusing both industrial and municipal effluents for raw water supplies. It is practiced mainly in areas where water is scarce and or expensive. This is proving a popular and economical method of conservation. Of all the sources of water available to industry, sewage plant effluent is the most reliable at all seasons of the year. Fifth method of reducing the volume is elimination of batch or slug discharges of process waste. During manufacturing process, one or two steps are sometimes repeated, which results in production of a significantly higher volume and strength of waste during that period. If this waste is discharged in a short period of time, usually referred to as a slug discharge. This type of waste, because of its concentrated contaminants and or surge in volume, can be troublesome to both treatment plants and receiving streams. There are two methods of reducing the effects of these discharges. First among them is the manufacturing firm alters its practice so as to increase the frequency and lessen the magnitude of batch discharges. Secondly, I can say sludge waste are retained in holding basins from which they are allowed to flow continuously and uniformly over an extended period. This particular period may be considered as 24 hours. So now come to the next method of treating the industrial wastewater, that is strength reduction. Waste strength reduction is the second major objective in industrial waste management. The strength of the waste can be reduced by the following methods. First among them is process change. Second one is equipment modification. Third one is segregation of waste. Fourth one is equalization of waste. Fifth one is byproduct recovery. Sixth one is proportioning waste. And seventh one is monitoring waste streams. Eighth one is accidental spills. Now we'll discuss in brief about all these methods of reducing the strength. As I told you, first process is method is process change. Let's have a break. Wait. Now, yes, Arpita Pawar.
Yes, sir.
Yeah, is it audible? Is it audible
Yes,
clearly?
sir.
Yeah, okay then. Let me continue. Okay, so we are discussing about the first method of reducing the strength of industrial wastewater, that is process change. Many industries have resolved waste problems through process change. For example, textile and metal fabricating industries. Textile finishing mills are faced with a problem of disposal of highly polluted waste from sizing, tearing, resizing, and dyeing process. Starch has been traditionally used as sizing agent. This starch, after hydrolysis, becomes a major source of waste pollutants. New substituent of starch, carboxymethyl cellulose, has been developed to solve above problem, which has reduced BOD value significantly. In the metal plating industry, several changes in the process have been suggested to eliminate or reduce cyanide strength. First among them is change from copper cyanide plating solution to acid copper solution. Second one is replace the copper cyanide strike before the copper bath with a nickel strike. Third one is substitute, that is H3PO4 for H2SO4 in pickling of steel. Now, fourth one I can say is use alkaline derusters instead of acid solutions to remove light rust which occurs during storage, that is storage. So the overall pH will be raised nearer to neutrality by this process, which will also alleviate corrosive effects on piping and sewer lines. Coal mining company has modified its process to wash raw coal with acid mine water rather than a public or private water supply. In this way, the mine drainage waste is neutralized, while the washed coal is free from any impurities. Second method of reducing the strength of the wastewater, that is done by mo- modifying the equipment, or else I can say the equipment modification. So with this also we can reduce the strength of the industrial wastewater. Changes in equipment can affect a reduction in the strength of the waste, usually by reducing the amounts of contaminants entering the waste stream. For example, in pickle factories, screens placed over the drain lines in the tanks prevents the escape of seeds and pieces of vegetables and fruits, which add to the strength and density of waste. Similarly, traps on the discharge pipeline in poultry plants prevents emission of feather and piece of fats. Waste strength reduction occurred in the dairy industry by redesigning the large milk cans used to collect farmers' milk. The new cans were constructed with smooth necks so that they could be drained faster and more completely. This prevented a large amount of milk waste from entering streams and sewage plants. And third one I can say is segregation of waste. Using this also we can reduce the strength. Segregation of waste reduces the strength and or the difficulty of treating the final waste from an industrial plant. For example, in metal finishing plants, which produce waste containing both chromium and cyanide as well as other metals, it is necessary to segregate the cyanide bearing waste, make them alkaline, and oxidize them. The chromium waste, on the other hand, have to be acidified and reduced. Two effluents, that is 2 TWO, two effluent can then be combined and precipitated in an alkaline solution to remove the metals. Without segregation, poisonous hydrogen cyanide gas would develop as a result of acidification. textile mill manufacturing finished cloth produced by the four types of waste such as grey waste, white waste, dye waste, and kite waste. The combined waste are quite strong, difficult, and expensive to treat. However, when the strong liquid tiring waste was segregated from the other waste, chemically neutralized, precipitated, and settled, the supernatant could be treated chemically and biologically along with other three waste because the strength of the resulting mixture was considerably less than that of the original combined waste. So this is how to reduce the strength of the industrial wastewater. Next method is to reduce the strength is equalization of waste. Main objective of equalization are to stabilization of pH, BOD, and settling of solids and heavy metals. Plants which have many products from a diversity of processes prefer to equalize their waste. This requires holding base for a certain period of time, depending on the time taken for the respective processes in the plant. For example, if a manufactured item requires a series of operations that take 8 hours, the plant needs an equalization designed to hold the waste for that 8 hours period. The effluent from an equalization basin is much more consistent in its characteristics than in each separate effluent to that same basin. Stable effluents are treated more easily and efficiently than unstable ones by industrial and municipal treatment plants. Sometimes equalization may produce an effluent which warrants no further treatment. Now, we'll discuss in detail on equalization of waste in the next class. Now, fifth method I can say that is used to reduce the strength of the industrial wastewater is byproduct recovery. This is the utopian aspect of industrial waste treatment. The one phase of this entire problem which may be led to economic economic gains. Economic gains. The industrial management should consider the possibility of building a recovery plant which will produce a marketable byproduct and at the same time solve a troublesome waste problem. For example, the dairy industry treats skim milk with dilute acid to manufacture casein. Casein manufacturers in turn utilize their waste to precipitate albumin. The resulting albumin waste is used in the crystallization of milk sugar, and the residue from this process is utilized as poultry feed. Second one, yeast factories evaporate a portion of their waste and sell residue for cattle feed. Third one, in sewage treatment plant, methane gas from sewage digester is commonly utilized for heat and power, and some cities digested and dried sewage sludge is used as a manure. The sulfite waste liquors byproducts from paper mills are used in fuel, road binder, cattle fodder, fertilizer, insulating compounds, and in production of alcohol and artificial vanillin. vanillin. Once a byproduct is developed and put into production, it is difficult to identify the new product with a waste treatment process. For example, when sugar is extracted from sugarcane, a thick slurry known as molasses is left. It has many uses. One of the best known being is the production of commercial alcohol, that is ethyl alcohol. Next method of reducing the strength is proportioning waste. By proportioning its discharge of concentrated waste into the main sewer, a plant can often reduce the strength of its total waste to the point where it will need a minimum of final treatment or will cause the least damage to the stream or treatment plant. In detail, we'll discuss in the subsequent chapters of the module. So seventh method of reducing the strength is monitoring waste streams. Remote sensing devices that enable the operator to stop, reduce, or redirect the flow from any process when its concentration of contaminants exceeds certain limits are an excellent method of reducing waste strength. In fact, accidental spills are often the sole cause of stream pollution or malfunctioning of treatment plants. These can be controlled. Eighth method of reducing the strength is accidental spills. Accidental discharges of significant process solutions represent one of the most severe pollution hazards. There are some measures that can be taken to reduce the likelihood of accidents and severity when and if they occur. Some suggestions for general use include: first among them is make certain that all pipelines and valves in the plant are clearly identified. Secondly, allow only certain knowledgeable person to operate these valves. Third one I can say is install indicators and warning system for leaks and spills. Fourth one is provide for detention of spilled wastewater in holding basins or lagoons until proper waste treatment can be accomplished. Last one I can say is monitor all effluents quantity and quality to provide a positive public record if necessary. So all these this particular notes which we have discussed is prepared by referring all these references. Okay, so you will get the copies in net or in our library. Just to go through these books if you want some more information about the topics which I have discussed. Now, what is the significance of these topics here? So these topics are very important in sanitary engineering and in municipal services, and also working as consulting environmental engineer. So now, the questions may be asked like this: what advantage do we get by reducing the waste volume? Secondly, I can say, what do you mean by strength reduction? Why should we use it? So, like questions may be asked in the examination. Now, Manjunath, yes, Bhimanalli. Manjunath, Manjunath SB. Yes, Sudha. Hello.
Yes, sir.
Yeah, is it audible?
Yes, sir. Audible, sir.
Okay then. Okay. Let me continue. Now, as I told you, in the next class, on the in the notes posted on 23/11/2020. So we have discussed about one of the method of industrial wastewater treatment, that is neutralization. So just you can go through the notes which I have posted on 23/11/2020. So before that, just now I have told you in the previous class we have covered value reduction and strength reduction. So as we have only one online class per week, I will discuss the notes which I have posted in the WhatsApp group for last week or 3 to 4 classes. Okay. So now, today we'll discuss, or in that, again we'll discuss one of the other method of treating the industrial wastewater, that is neutralization. So acid or alkaline waste should not be discharged without treatment into a receiving stream. There are many acceptable methods for neutralizing over acidity or over alkalinity of wastewater, for example, such as first one, mixing waste; second one, limestone treatment for acid waste; third one, lime slurry treatment for acid waste; fourth one, caustic soda treatment for acid waste; fifth one, waste boiler or fuel flue gas; sixth one, carbon dioxide treatment for alkaline waste; seventh one, producing carbon dioxide in alkali waste; and sulfuric acid treatment for alkaline waste. The volume, kind, and quantity of acid or alkali to be neutralized are the main factor to be kept in mind to decide what kind of neutralizing agent is to be used. In any lime neutralization treatment, adequate reaction time for an acid effluent should be given so that they can reach minimum pH value. So now we'll discuss in brief all these methods of neutralization. Come to the first one, that is mixing waste. Mixing of waste can be accomplished within a single plant operation, or between neighboring industrial plants. Acid and alkali waste may be produced individually within one plant, and proper mixing of these waste at appropriate time results in neutralization. For example, I can say if one plant produces an alkaline waste which can be pumped conventionally to an area adjacent to a plant discharging an acid waste, an economical and feasible system of neutralization results in each plant. Second one I can say is limestone treatment for acid waste. In this method, acid wastes are passed through beds of limestone, that is calcium carbonate, at a rate of about 1 gallon per minute per square feet. So that is 1 GPM per feet square. Neutralization takes place with the following reaction. Calcium carbonate reacts with the sulfuric acid to convert, or there will be conversion of calcium carbonate into calcium sulfate and H2CO3. This reaction will continue as long, just a second. Sorry for the inconvenience. This particular reaction will continue as long as excess available and in an active state. The first condition can be fulfilled by providing a sufficient quantity of limestone. The second condition is difficult to meet because excess of acid will precipitate calcium sulfate and cause subsequent coating and inactivation of the limestone. Disposing of the used limestone beds can be a serious drawback to this method of neutralization, since the use of limestone must be replaced by fresh at periodic intervals. Frequency of replacement depending on the quantity and quality of acid waste being passed through a bed. When there are extremely high acid loads, foaming may occur, especially matter is also present in the waste. Third method of neutralization is lime slurry treatment for acid waste. Mixing acid waste with lime slurries is an effective procedure for neutralization. The reaction is similar to that obtained with limestone beds, but the advantage of using lime slurry than limestone beds are, first one is, in this case, lime is used up continuously because it is convenced, convened to calcium sulfate and which is carried out in the waste. Second one is lime processes a high neutralizing power and its action can be hastened by heating or by oxygenating the mixture. Third one I can say is it is relatively inexpensive, but in large quantities the cost can be an important item. Neutralization of the nitric and sulfuric acid base in concentration up to about 1.5%, that is in case of sulfuric acid, that is H2SO4, was accomplished satisfactorily by using a burned dolomite stone containing 47.5% of calcium oxide. So 34.3% magnesium oxide and 1.8% of calcium carbonate. So next method of neutralization is caustic soda treatment for acid waste. Concentrated solutions of caustic soda or sodium carbonate cause neutralization of acid waste. These neutralizers are more powerful than lime or limestone, and some agents are required in small value. Another advantage is that the products are soluble and thus they do not increase the hardness of receiving waters. When sodium hydroxide is used as a neutralizing agent for carbonic and sulfuric acid waste, the following reaction takes place. So these are the reactions which takes place. Just you can go through it. This sodium carbonate plus CO2 plus H2O will give Na, that is carbonic acid waste, along with carbonic acid waste as 2NaHCO3. So just you can go through these chemical equation. Both these neutralization take place in two steps, that is TW2 steps, and end products depend on the final pH desired. For example, I can say one treatment may require a final pH of only 6 and the most of end product is sodium bisulfate. Another treatment may require a pH of 8 with most of product being sodium Na2SO4, that is sodium sulfate. Now next method of neutralization is that is neutralization of alkaline waste using waste boiler fuel gas. It is most economical method for neutralizing of alkaline waste. In this method, when waste boiler flue gas containing around 14% of carbon dioxide is passed through the alkaline waste, then CO2 dissolve in wastewater and will form carbonic acid. That is a weak acid, which is in turn reacts with caustic waste to neutralize the excess alkalinity as shown below in chemical reaction. So just you can go through these chemical reactions. So sixth method of neutralization is carbon dioxide treatment for alkaline waste. Bottled carbon dioxide is applied to wastewater which neutralize alkaline waste on the same principle as boiler flue gas. That is, there will be formation of weak acid, that is carbonic acid, which again reacts with the alkaline waste part of the wastewater. Now next method of neutralization is producing carbon dioxide in alkaline waste. Carbon dioxide produced by fermentation of an alkaline organic waste help in neutralization of alkaline waste by decreasing the pH. Similarly, by fermenting alkaline fat sugar based with E. Carbon dioxide is produced, which can be used for neutralization. So, eighth method is sulfuric acid treatment for alkaline waste. The addition of sulfuric acid to alkaline waste causes neutralization. In this method, storage and feeding equipment requirements are low due to high acidity value of N3SO4. Sorry, there is a print mistake, SO4, but it is difficult to handle because of its corrosiveness. The neutralization reaction which occurs when it is added to wastewater will be as follows. There is sodium hydroxide plus sulfuric acid will lead in the formation of Na2SO4 and water. A titration curve of an alkaline waste neutralized with various amounts of sulfuric acid is helpful to determine the quantity of acid required for neutralization. This is the titration process. This is trial. This particular graph is plotted with the help of trials, taking different trials of mixture of acid and bases. And we can study the variation of pH when we add acid to the alkaline solution. So this particular notes is also prepared by referring all these books here. So just if you want, you can refer these books or if you want any more information about the topic of neutralization. As I told you, these topics are very important in sanitary engineering, municipal services, as well as if you want to work as consulting environmental engineer. The question may be asked like this: write down the name of the main of both alkaline and acid waste. This particular question may be asked for 6 to 8 marks here. Now, let me discuss another method of treating the industrial wastewater. Yes, because
Yes, sir.
yeah, is it audible clearly?
Yes, sir.
Okay, then let me continue. So previously we were discussing about the one of the method of treating the industrial wastewater, that is neutralization. Let me discuss in brief about another two methods of treating the industrial wastewater. That is, first one is equalization and second one is proportioning. Let me discuss in brief about equalization. Equalization is a method of retaining waste in a basin so that effluent discharge is, first one, uniform in its sanitary characteristics. Characteristics considered are pH, color, turbidity, alkalinity, and BOD, that is biological oxygen demand. Secondly, concentration of effluent contaminants is lowered. Third one, I can say physical, chemical, and biological reaction takes place. Sometimes air is injected into these basins to provide, first one is better mixing, second one is chemical oxidation of reduced compounds, third one is some degree of biological oxidation, and fourth one, agitation to prevent suspended solids from settling. Now come to the objectives of equalization here. So the equalization is done to provide adequate dampening of organic fluctuation in order to prevent shock loading of biological system. Secondly, I can say to provide adequate pH control or to minimize the chemical requirements necessary for neutralization, necessary for, sorry, it is repeated here, necessary for neutralization. Third objective is to minimize flow surges to physical chemical treatment system and permit chemical feed rates compatible with feeding equipment. Fourth objective is to provide continuous feed to biological system over periods when the manufacturing plant is not operating. Fifth objective is to provide capacity for controlled discharge of waste to municipal discharge of waste to municipal system in order to distribute waste loads or, more. Sixth objective is to prevent high concentration of toxic material from entering the biological treatment plant, which may lead into the death of the microorganisms. The size and shape of the basin vary with quantity of the waste and the pattern of discharge from the factory. Most basins used for equalization are rectangular, square, triangular in shape. The capacity of the tank should be adequate to hold all the waste from the plant. Almost all industrial plants operate on a cycle basis. Thus, if the cycle of operation is repeated every 2 hours, an equalization tank which can hold a 2-hour flow will usually be sufficient. If the cycle is repeated only each 24 hours, the equalization basin must be high enough to hold 24 hours flow of waste. The mere holding of waste, however, is not sufficient to equalize it. Each unit volume of waste discharge must be adequately mixed with other unit volumes of waste discharged many hours previously. This mixing may be brought about in the following ways. First one is proper distribution and baffling. Second one is mechanical agitation. Third one is aeration. And fourth one is combination of all the three. So for proper distribution and baffling. What do you mean by this? Proper distribution and baffling is the most economical, though usually the least efficient method of mixing. Still, this method may suffice for many plants. Horizontal distribution of the waste is achieved by using either several inlet pipes spaced at rectangular intervals across pipes spaced at regular intervals across the bed of the tank, or perforated pipes across the entire bed. Over and under baffles are advisable when the tank is wide because they provide more efficient horizontal and vertical distribution. So this is the line diagram of baffled equalization tank. The vertical lines will show the over and under baffles, and this is the influent, that is this is the entry of influent, and effluent is taken out at this particular point. Now, second method is mechanical agitation. Mechanical agitation eliminates most of the need for baffles and generally provides better mixing than baffles alone. One typical arrangement is shown in following figure. Uses three wooden gate type agitators spaced equidistantly along the center line, equidistantly along the center line of the length of the tape. Agitators operated at a speed of 15 rotations per minute by 3 horsepower motor are usually adequate. So this is how we can provide the mechanical agitators for the process of equalization of waste. So this is the side view of an equalization basin with mechanical agitator instead of baffles. Agitation means it's a mixing. Okay. So this is the pictorial view of the equalization tanks. This is a kind of equalization tank again. You can see such arrangement in the industries. Now come to the next method of treating the industrial wastewater, that is proportioning. Proportioning means the discharge of industrial waste in proportion to the flow of municipal sewage in sewers. In most cases, it is possible to combine equalization and proportioning in the same vessel. The objective of proportioning in sewer is to keep constant the percentage of industrial waste to domestic sewage flow entering the municipal sewage plant. This procedure has several other purposes also. First among them is to protect municipal sewage treatment plant using chemical by sudden overdose of chemicals contained in the industrial waste. To protect biological treatment devices from shock loads of industrial waste which may inactivate the bacteria. Third one, to minimize fluctuation of sanitary standards in the treated effluents. The rate of flow of industrial waste varies from instant to instant, as does the flow of domestic sewage, and both empty into the same sewage system. Therefore, the industrial waste must be equalized and retained, then proportioned to the sewer or stream according to the volume of domestic sewage or stream flow. To facilitate proportioning, an industry should construct a holding tank with a variable speed pump to control the effluent discharge. But in some cases, domestic sewage treatment plant is usually located some distance from an industry, hence signaling the time and amount of flow is difficult and sometimes quite expensive. To solve this problem, many industries have separate pipelines through which they pump their waste to the municipal treatment plant. The wastes are equalized, separated at the site of the municipal plant and proportion to the flow of incoming municipal wastewater. Separate lines are not, of course, always possible or even necessary. So this is the graphical representation of the mixing of the industrial wastewater with domestic discharge in the STP, that is sewage treatment plant. Now come to the methods of proportioning. There are two general methods of discharging industrial waste in proportion to the flow of domestic sewage at the municipal plant. First among them is manual control related to a well. Manual control related to a well-defined domestic sewage flow pattern, and manual control is lower in initial cost but less accurate. It involves determining the flow pattern of domestic sewage for each day of the week over a period of months. Usually, one does this by examining the flow records of the sewage plant or by studying hourly water consumption figures for the city. Apart from this, we can also use another method, that is automatic control of waste discharge according to sewage flow. It involves placing a that registers the amount of most convenient main sewer connection. This device translates the rate of flow in the sewer to a recorder located near the sewer to a recorder located near the plant's holding tank. The pen on the recorder accurates either a mechanical, that is nothing but gear, or a pneumatic, that is air, control system for opening or closing the diaphragm of the pump. There are, of course, many variations of automatic flow control system. Although their initial cost is higher than that of manual control, they will usually return the investment many times by the savings in labor cost. So this particular notes is also written using the books as well as referring the website. These topics are very important in sanitary engineering, municipal services, as well as if you want to work as consulting environmental engineer. So, question in the examination may be asked to write short notes on equalization and proportioning. Okay. Any doubt? Any doubt in the topics? Yes, Jai Shri Hiramat, is there any doubt?
No, sir.
Okay, then let me conclude this class, and in the next online class we will discuss about another method of treating the industrial wastewater, that is removal of organic solids, and also we'll discuss about the removal of inorganic solids, colloidal solids, and other topics which I cover from that is 27th to coming first week of December. Okay, thank you one and all.